Imagine holding a single brick in your hand. It looks simple, almost ordinary. But here's what nobody tells you. That small block may have survived temperatures hotter than a volcanic lava flow and traveled hundreds of miles before reaching a construction site. Most people never think about this, yet billions of bricks quietly support the homes, schools, factories, and cities that shape our lives every day. Think about this. Every year, the world produces more than 1 trillion bricks. If you line them up end to end, they could wrap around Earth thousands of times. Yet almost nobody knows what happens between the moment clay leaves the ground and the moment a finished brick becomes part of a building. And this is where it gets truly extraordinary. Today, we're going inside one of the world's most fascinating manufacturing processes. You'll see giant excavators tearing into ancient clay deposits, machines shaping thousands of bricks every hour, and kilns glowing like artificial suns. What happens next surprised even experienced engineers. By the end of this journey, you'll never look at a brick the same way again. Every brick begins with earth. The primary ingredient is clay, a natural material formed over millions of years as rocks slowly broke down under weather, pressure, and water. Major brick-producing countries such as China, India, the United States, and the United Kingdom extract clay from open-pit mines located close to manufacturing plants. A typical brick factory may consume hundreds of tons of clay every single day. Not all clay is equal. Manufacturers carefully test mineral composition before excavation begins. High-quality brick clay often contains between 50 and 70% silica, 10 to 20% alumina, and smaller amounts of lime, iron oxide, and magnesium compounds. Those minerals determine everything from color and strength to durability and resistance against weather. Most people never think about transportation. After extraction, giant dump trucks carrying 20 to 50 tons of clay move continuously between mines and processing facilities. Some factories position themselves less than 10 miles from clay deposits to reduce fuel costs and emissions. Others transport raw materials over hundreds of miles by rail when specialized clay grades are required. But clay alone isn't enough. Many manufacturers blend sand into the mixture to improve dimensional stability during firing. Fine sand particles reduce shrinkage and help bricks maintain precise shapes. In some facilities, recycled brick waste returns to the process, reducing landfill disposal while improving production efficiency. Water plays a surprisingly important role. Massive pumps deliver thousands of gallons every day into mixing systems where moisture levels remain carefully controlled. Too much water weakens the structure. Too little water prevents proper shaping. Engineers often monitor moisture content within fractions of a percent because even small variations can affect the final product. Environmental concerns have transformed the industry over the last 2 decades. Modern clay mines restore landscapes after extraction, replacing topsoil and planting vegetation to reduce long-term ecological impact. Some companies now recycle wastewater and use renewable energy sources to lower carbon emissions. Yet brick production still consumes enormous amounts of energy, creating a challenge engineers continue to tackle. And then comes a step that looks surprisingly simple but determines the fate of every brick that follows. Deep inside the factory, raw clay begins a transformation that will expose it to crushing pressure, precise shaping, and temperatures exceeding 1,000 degrees Celsius. What happens next turns ordinary earth into one of humanity's oldest engineering materials. The transformation begins the moment raw clay enters the preparation line. Giant crushers equipped with steel rollers break down large chunks into particles just a few millimeters across. The machines growl continuously as hundreds of tons of material move through every day. Imagine standing nearby and feeling the ground vibrate beneath your feet as ancient earth begins its journey toward becoming a brick. Next, the crushed clay enters a mixer where engineers carefully add water until moisture levels reach approximately 15 to 20%. Massive paddles rotate at speeds between 30 and 60 RPM, folding the mixture again and again until it becomes smooth and uniform. The smell of wet earth fills the air. Most people never think about this, but a tiny change in moisture can determine whether a brick survives the furnace or cracks before it ever leaves the factory. The prepared clay now moves into a vacuum chamber. Here, powerful pumps create pressures as low as 0.1 bar, removing trapped air bubbles that could weaken the finished product. What happens next surprised even experienced engineers. A defect smaller than a grain of rice can become a fracture point capable of destroying a brick during firing. Now comes the shaping process. The clay is forced through a steel extrusion die under pressures reaching 300 to 600 psi. A continuous column of clay emerges from the machine like an endless ribbon. As it slides forward, automated cutting wires slice it into individual bricks with astonishing precision, producing thousands of units every hour. Freshly formed bricks look complete, but they're surprisingly fragile. At this stage, they still contain significant moisture and can deform under their own weight. Robotic systems carefully place them onto drying racks while conveyors transport them toward the next critical stage. One careless movement could ruin hundreds of bricks in seconds. The drying chambers feel more like giant climate-controlled laboratories than factory rooms. Heated air circulates continuously between 50 degrees Celsius and 120 degrees Celsius, or 122 degrees Fahrenheit to 248 degrees Fahrenheit. Fans move air at carefully controlled speeds to remove moisture gradually. This process may take anywhere from 24 to 72 hours depending on brick size, climate, and composition. As water leaves the clay, the bricks shrink slightly. Engineers expect this and design every mold accordingly. Sensors monitor humidity, temperature, and airflow around the clock because uneven drying creates internal stress. Most people never see this stage, yet it determines whether a brick becomes strong or fails before reaching the kiln. Then comes the moment everything has been leading toward. Conveyor systems slowly feed thousands of dried bricks into a tunnel kiln stretching hundreds of feet long. Inside, temperatures climb from a few hundred degrees to more than 1,000 degrees Celsius, or 1,832 degrees Fahrenheit. The heat radiating from the entrance feels like standing beside an open blast furnace. And this is where it gets truly extraordinary. As temperatures rise above 900 degrees Celsius, complex mineral reactions begin inside the clay. Tiny particles fuse together in a process called vitrification, creating the hardness and durability bricks are famous for. What started as soft earth now becomes a ceramic material capable of lasting for centuries. The firing cycle can last between 24 and 48 hours. Every zone inside the kiln performs a different task, gradually heating, firing, and cooling the bricks. The roaring sound of burners echoes through the structure, while sensors continuously track temperatures with remarkable accuracy. A difference of only a few degrees can affect the final color and strength. After firing, the bricks cannot cool too quickly. Controlled cooling chambers slowly reduce temperatures over many hours to prevent thermal shock. Workers inspect the first batches emerging from the line, checking color, texture, and shape. For the first time, the finished product finally resembles the brick you recognize. But here's the mystery. Even after surviving crushing forces, drying chambers, and temperatures hotter than many volcanic eruptions, not every brick makes the cut. The next stage uses advanced technology capable of detecting flaws invisible to the human eye. And some of the machines making those decisions are smarter than you might expect. Thousands of freshly fired bricks now move through one of the most sophisticated inspection systems in modern manufacturing. At first glance, the line looks simple, but hidden above the conveyors, dozens of sensors, cameras, and computers analyze every brick that passes below. Most people never think about this, yet these machines make thousands of quality decisions every single hour. The first inspection focuses on dimensions. Laser measurement systems scan every surface and compare results against digital specifications. A standard brick may require dimensional accuracy within plus or minus 2 millimeters. If a brick exceeds those limits, automated systems instantly remove it from the production line without slowing the process. Next comes visual inspection powered by artificial intelligence. High-speed cameras capture multiple images of each brick from different angles. AI software searches for cracks, chips, warping, discoloration, and surface defects that human eyes might miss. Some systems analyze hundreds of bricks every minute with remarkable consistency. What happens next surprised even experienced engineers. Certain microscopic defects remain completely invisible on the surface. To find them, some factories use ultrasonic testing systems that send sound waves through the brick. If internal fractures exist, the returning signal changes instantly, revealing hidden weaknesses before the product ever reaches a customer. Quality control doesn't stop at inspection. Every production batch undergoes destructive testing. Workers select sample bricks and place them into hydraulic compression machines capable of generating enormous force. The goal sounds strange. Engineers deliberately try to break the product they just spent days creating. A high-quality structural brick may withstand compressive strengths exceeding 20 megapascals, while premium engineering bricks often exceed 70 megapascals. That's enough pressure to support tremendous loads over decades of service. Imagine the weight of entire building sections resting on materials that began as ordinary clay only days earlier. Water absorption testing provides another crucial measurement. Engineers weigh bricks, soak them in water for precise periods, then weigh them again. Excessive absorption can reduce long-term durability in harsh weather conditions. The numbers may seem small, but tiny differences can dramatically affect performance over decades. Factories producing premium products often maintain rejection rates between 1 and 3%. That may sound low, but when millions of bricks leave the plant every year, even a single percentage point represents thousands of rejected units. Quality always costs money, but failure costs far more. International certifications add another layer of scrutiny. Manufacturers commonly follow standards such as ASTM requirements in North America and EN specifications across Europe. Auditors review production records, testing procedures, and consistency data to ensure every batch meets strict requirements. Behind every approved brick lies an enormous amount of documentation. Yet despite all this automation, one area still depends heavily on human skill. Experienced inspectors can often recognize subtle color variations that indicate firing inconsistencies long before software detects a problem. Years of experience train their eyes to notice patterns hidden within thousands of nearly identical bricks. Sometimes human intuition still beats the machine. Finally, robotic palletizing systems stack finished bricks into perfectly organized bundles. Industrial robots move with incredible precision, lifting hundreds of pounds repeatedly without fatigue. Protective wrapping secures each load for transportation. The journey from raw earth to finished product is nearly complete. But here's something few people realize. The scale of global brick production is so massive that the numbers almost sound impossible. Billions become trillions. Entire nations depend on this industry. And the story behind those numbers reveals just how important a simple brick truly is. Think about this. Humanity produces well over 1 trillion bricks every single year. That's enough to build countless homes, schools, hospitals, factories, and entire cities. If those bricks were placed end to end, they would circle the earth thousands of times. Most people see a brick as something small, but on a global scale, brick manufacturing ranks among the largest industries on the planet. The global brick market generates tens of billions of dollars every year. Construction demand drives this enormous industry as growing populations require new housing and infrastructure. Developing economies continue expanding rapidly, creating a constant need for affordable and durable building materials. Behind every skyline, there's a hidden army of brick manufacturers working around the clock. China remains the world's largest producer, accounting for a significant share of global output. India follows closely behind, supplying vast quantities for one of the fastest-growing construction markets on Earth. Countries such as Pakistan, Bangladesh, and Vietnam also maintain enormous brick industries, while the United States and several European nations focus increasingly on high-efficiency automated production. The industry provides employment for millions of people worldwide. From miners and machine operators to engineers, laboratory technicians, logistics specialists, and construction workers, countless careers depend on the humble brick. Most people never think about this vast workforce, yet entire communities rely on brick production for economic survival. But the story of bricks didn't begin in modern factories. Archaeologists have discovered evidence of brickmaking dating back more than 9,000 years. Ancient civilizations in Mesopotamia used sun-dried bricks to construct some of humanity's earliest cities. Long before steel skyscrapers and concrete towers existed, bricks helped transform scattered settlements into organized civilizations. Did you know that some ancient brick structures still stand after thousands of years? In many cases, the bricks have outlasted entire empires. Wars, floods, earthquakes, and centuries of weather have destroyed countless buildings. Yet many fired bricks remain remarkably intact. That's a level of durability few modern products can match. Did you know that the color of a brick often comes from iron compounds inside the clay? During firing, those minerals react with heat and oxygen to create shades ranging from bright red and orange to brown, purple, and even nearly black. What appears to be simple color is actually chemistry visible to the human eye. Did you know that modern tunnel kilns operate continuously for months at a time? Shutting them down unnecessarily wastes enormous amounts of energy and disrupts production schedules. Some facilities function almost like living organisms, running day and night with only carefully planned maintenance interruptions. Over the last 50 years, brick manufacturing has changed dramatically. Manual labor once dominated the process, but automation now controls many critical stages. Advanced robotics, AI inspection systems, energy-efficient kilns, and environmental monitoring technologies have transformed productivity while improving consistency and reducing waste. Looking ahead, engineers are developing lower carbon production methods, alternative fuels, smarter kilns, and advanced recycling systems. Some researchers are even experimenting with new brick formulations that require less energy during firing. The goal remains the same as it was thousands of years ago: create stronger, more durable building materials while using fewer resources. From ancient clay deposits buried beneath the ground to sophisticated factories filled with lasers, robots, and furnaces hotter than volcanic eruptions, the journey of a brick is far more complex than most people imagine. Every stage demands precision, engineering, and an extraordinary amount of energy. Millions of these small building blocks quietly support the modern world around us. And now you know the incredible story hidden inside every single one. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.